Algebra of Matrices, Part 2. We've been looking at adding and subtracting matrices, scalar multiplication. When we add or subtract matrices, we have to remember they must be of the same size. As long as they're of the same size, we can add or subtract corresponding entries. If we look at a scalar multiplication, we take that scalar, which is a constant, and we multiply every entry inside of the matrix by that scalar or by that number. So here, if we look at this first example, C minus B, we're going to take here matrix C, we're going to take here matrix B, and we want to subtract them in this order. Matrix C is 2 rows, 3 columns for its size. Matrix B is 2 rows, 3 columns for its size. Because the sizes are the same, we're able to subtract these two together. We subtract corresponding entries in the order that it asks. C minus B. So 2 minus 3 is going to give us a negative 1. Negative 5 halves minus 1 halves is a negative 6 halves. Negative 6 over 2 reduces to negative 3. 0 minus 5 is a negative 5. 0 minus 1 is a negative 1. 2 minus a negative would make that a plus. 2 plus 1 would give us a 3. And then a negative 3 minus 3 would give us a negative 6. And there's our subtraction. Now in this next one, we have more than subtraction going on. We also have scalar multiply and subtraction. So in this one, let's go ahead and put these in our calculator and work with our calculator. Okay, so we're going to say second matrix edit. We're going to put in matrix C. Matrix C, remember, was a 2 by 3. So we'll go ahead and put in that size. And then put in our entries. So we have 2. We have negative. We have a negative 5 over 2. We have 0. We have 0, we have 2, we have negative 3. Okay, we'll hit second quit. We'll hit second matrix edit. Matrix B, we'll go ahead and put that in matrix B. Matrix B is also 2 by 3. So let's go ahead and put in that size. 2 by 3. Matrix B is 3, 1 half, 5, 1, negative 1, and 3. Okay, I always make sure that I put in the right numbers. So I'm going to bring up matrix C. I'm going to double check that I put in everything looks good. Matrix B. We're going to make sure everything was in order, everything put in correctly. If I don't put in the correct numbers, I'm not going to get out a good solution. Okay, so now we're just going to take matrix C minus matrix B, and it's that easy. Matrix C minus matrix B is just like we got by hand. There's our solution. Now what I wanted to do is then, since we have more than one operation, maybe getting the calculator to do the work for us is an option. And it's just this easy. 2 times matrix C minus 6 times matrix B. So if we have 2C minus 6B, there's our solution. Okay, so in this case we had a few operations going on, so maybe our calculator will help us get at the answer quicker. Our next example, we have addition, 3B plus 2C. Okay, so we make sure to check our sizes. Looking at matrix B, matrix B is 2 rows, 3 columns. Matrix C, Matrix C, again, we have 2 rows, 3 columns. Because the sizes match, we're able to get these added. We're going to get these added together. Add or subtract, you must have the same size. Okay, so we're going to take 3 times matrix B plus 2 times matrix C There's our quick solution. This one involves a fraction. So if I go to the math menu and I say option 1, answer in fraction, I get my fractional form for my answer, which is preferred. Okay, so let's look at problem number 26b. We have that constant 2 times h, so that's scalar multiplication, and then we have added to d. So we're multiplying the scalar 2 times h, and then we're going to add that to matrix D. Okay, so before we do anything, we always check our sizes. Okay, so here's matrix H. Matrix H is 2 rows, 2 columns. Here is matrix D. If we look at matrix D, that's 1 row, 2 columns. Unequal sizes. Unequal sizes tell us that this is not possible. Not possible, unequal sizes.